All right, so the first ones are just solving simple equations. Remember, to get the x by itself, to figure out what it is, you just do the opposite. It's a minus, so you add 4.7. And you get negative 2.5. Here, it's a minus 9, so you add 9, and you get negative 6. Two-step, remember, get the x by itself. Anything not attached to it goes first. So to get rid of that positive 20, I got to subtract 20. Do the same to the other side. You get negative 8, drop the equal sign down, and then don't forget that's still a negative 4x. So then you divide by negative 4 and you get 2. Another two-step, get the x by itself. 4 is attached to it, so that goes last. So get rid of the minus 3 by adding 3. That makes 0. Add 3. That's still a negative 4x. So then divide by negative 4 and you get negative 2. Solving systems of equations. This first one is set up, you can solve them any way you want. The first one is set up as a substitution. Since the y is by itself, you can just substitute this in for that y. So you rewrite this equation. X plus 2, but in place of the y, you put what y is equal to, half of x minus 2. Equals 2. And then you solve it. So you got to multiply the 2 times everything. 2 times a half of x is 1x, or just x. 2 times negative 2 is negative 4, equals 2. You can combine those x's, and then you just solve it. Add 4, divide by 2, and you get x equals 3. Then, don't forget, you got to also find y. So all you do is you put x back in. A half of 3 is 1.5. Take away 2 is negative a half, or negative 0.5. Now, substitution gets a little more confusing. It's quicker if it's set up this way, but elimination is always the easiest. In order to do elimination, everything has got to be lined up. So all I'd have to do here is move this over, and then the y's would be lined up, the x's, the equals, and so on. So this first one stays the same. This one, the 3y stays there. I move it over. Anytime you move a term, it just changes signs. So now the equal sign is right there, and then that didn't move, so it stays. Now another thing you can do, if you've got fractions in it, remember you can change it however you want as long as you change everything. If I take everything times 3, the reason why I chose 3 is because then they'll cancel. So then I would get 3y. Here the 3's cancel, so I'm just left with negative 4x. Equals 3 times 2.5 is 6, 7.5. Now, elimination, remember, you add or subtract the columns, and you want to get either the x or the y to cancel, one or the other. In this case, they're both going to cancel. Because if I subtract, 3y minus 3y is 0, and when I subtract there, remember you change the sign, those cancel, so I get 0. But when I subtract here, I don't get 0. If it ends up being 0 equals 0, that's true, so it's many solutions. But since 0 doesn't equal negative 9.5, it's a no solution. So this one, you could do the same way as this. First of all, what I would do is get rid of the fractions. To get rid of this, 2, take everything times 2. So 2 times y equals, here the 2's cancel, leaving you with 3x, plus 2 times 2 is 4. Do the same thing in this one. Take everything times 2. 2 times y is 2y, minus, here the 2's cancel, I'm left with 1x, equals, the 2's cancel, 1. So again, it's not lined up. So what I would have to do is if I move this over, then they'd be lined up. So the 2y would stay there. I'm just switching that one, and you can write them in any order, it doesn't matter. I move this over, I change to a negative 3x, equals, I didn't move that, so it just stays there. Now, the y's are lined up, the x's, the equals, the numbers. So I can get the y's to cancel if I subtract. 2y minus 2y is 0. Negative x take away negative 3x, remember you change the sign, you get 2x. 1 take away 4 is negative 3. So when I divide by 2, I get negative 1.5 for x. Then you got to plug it in to one of the equations. It doesn't matter, this is the easiest one. Put negative 1.5 in there. So remember, this is just 3 divided by 2 times negative 1.5 plus 2. And I get negative 0.25. Okay. This one is set up, you could solve it however you want, but it's set up to write a system of equations. It costs 7 cents to send a text message and 12 cents to send a picture. You spend $3.38. So what that means is 7 cents for every text plus 12 cents for every picture equaled $3.38. You sent twice as many texts as pictures. So your next equation, you just start off like that, text equals pictures, but it doesn't. You sent twice as many of these, so there's 2 times more here than here. So in order to make it equal, I would have to double the p. Now they're equal. So I have t equals 2p. Now this is set up for substitution like we did here because the t is by itself. Put that in place of the t. So you rewrite this 0.07p or 2p times t, which is now 2p, plus 0.12p equals 338. So 0.7 times 2 is 0.14p, and you can combine it with that. 0.14 and 0.12 is 0.26p equals 338. So then you just divide by 0.26. And you get 13. So the pictures is 13, but they're asking for the text messages, so you got to figure out what that is. Well, all you do is, we know P is 13, so put 13 in there. 2 times 13 is 26. Okay, a mapping diagram. That's just when you got the 2 circles. This is your x, this is your y. 0 is the x, and it maps to the 1. 2 goes to 5. 4 to 1, and 3 to 2. That's all a mapping diagram is. Okay, here we got a graph. There's the x-axis, there's the y. So if x is 0, y is 0. If x is 4, y is 3. Let's see, we got to go up to 12 and 9. Well, this is set up to go by 4s. And this one goes by 3s. You got to make sure you label that though. So 4 over 3 up, 8 over 6 up, 12 over 9 up. So it would go like that. Write a linear function. Y equals mx plus b. M is the slope. So remember, all you do here is you look at, this goes up 3 each time. This goes up 4 each time. Remember though, it's y over x. So you got to put the 3 over 4. So that's the number of the slope. Plus b is where it intercepts the y-axis, which it's at 0. So then what's the cost of 6 peaches? You just put 6 in there. 3/4 times 6 is 4.5. Yep. 4.5, which is $4.50. Linear or nonlinear? Linear means straight. If it's just an equation, what you look at is it can't have any exponents. There's an exponent, so that's no. Anything with an exponent is going to have a curve in it. This one doesn't have any exponents, so it's yes. When it's a function table, you just look to make sure they go up the same. Down 4, down 4, down 4, up 2, up 2, up 2. So that's a yes. Up 2, up 4. So that's no. Evaluate means solve. So square root of 169, you can figure that out on your calculator, is 13. The negative's on the outside, so it stays there. So it's negative 13 minus 7 is negative 20. Square root of 361 is 19, plus 8 is 27. What two integers is this number between? Well, if you didn't have a calculator, 30 is in between 25 and 36. The reason why I chose those is because they're perfect squares. Square root of 25 is 5, and it's negative. Square root of 36 is 6, and it's negative. So that means this number is between negative 5 and negative 6. Now all you'd have to do is put that number in. Negative square root of 30 is negative 5.47, and on and on and on. So then you can see it's between negative 5 and negative 6. Right triangles. If you know two sides, you can find a third. It's a squared plus b squared equals c squared, which is the leg squared plus the leg squared, because a and b are always the legs, equals the hypotenuse squared, which is opposite the 90. So 12 squared plus 9 squared equals x squared. Now remember, at the end of us, you're going to have to get rid of the squared, so you're going to end up square rooting it. So you take the square root of 12 squared minus 9 squared, and you end up getting 15. Here, this one's a little different because it's a leg that's missing. So if you wrote it out, it would be 6 squared plus x squared, the leg squared plus the leg squared, equals the hypotenuse squared. So here, you would have to subtract 6 squared to get the x by itself, and you'd get 64. Then you would square root, again, because you got to get rid of that squared, and you'd get 8. So the shortcut is, if you remember, if it's the two legs you know, if you're looking for the hypotenuse, you square them and add them, and then square root. If it's a leg you're looking for, you square them and subtract them, and then square root. So here, since it's a leg you're looking for, you square them and subtract them. Because remember, it's leg squared plus leg squared. And when we don't know a leg, we can't add them. So it'd be the hypotenuse squared minus the leg squared, square rooted. That's an x, by the way. And you get 27. Then we got the exponents. When it's the same base, you just add the tops. 27 plus negative 29 is negative 2. Remember, if it's negative, you got to put it underneath, so it's 1 over 12 squared. It says evaluate, so that's 1 over 144. This one, everything is to a negative power, so what I would do is just move it underneath. So everything goes underneath, which means there's nothing left, so you got to put a 1 on top. Negative 3 cubed to the first. So power to a power is just 3. Negative 3 to the third is negative 27. Same base, so you can just cancel. There's 2 more of those on top. So then when you square the negative, remember it's in parentheses, so you got to square the negative and the 6, would give you positive 36. And then the scientific notation using the calculators. Remember, you'd put in 4. You don't need to put the 0.0, but you can. Hit the EE button, or some of you might have the EXP button, which is usually down on the bottom if you have an EXP, not always, but sometimes. If anyone uses this one, it's down here. And then all you do is put in the exponent. You don't put the times 10, you don't do the caret key. That's what this button does for you. Times 2.5 EE negative 4. And you get 1. Now, some calculators may say this, that if you write it that way, you're going to get a point taken off, because that's not scientific notation. The E is times 10 to the negative 4th. You got to write it that way. So this one, you do the same way. 6 to... You get 9 times 10 to the negative 18. Again, this calculator doesn't write it like that, it just puts this. But you've got to put it into actual scientific notation. If you write it that way, you're going to get 2 wrong.